Let's have a look at this example. They give us a function y is equal to x squared plus 2x minus 3. They want us to find the x-intercepts, or the zeros, or the roots, and the y-intercept, and then calculate the x value for the turning point of the curve. If we look at the function, we see that the x2 term is positive, so we know that it's going to be like a smiley, something like this, U shape, which means that the function will have a minimum. Let's have a look at these examples, and I'm just going to make this full screen. So basically, to find the x-intercept, we have to factorize this expression. Okay, so we have x squared plus 2x minus 3. Just factorize it, and then we find out when is this expression 0, or when is the function 0, which is the same thing as saying when is the y value 0, because that's where we're crossing the x-axis. So either this factor, x minus 1, is going to be 0, and then the whole expression will be 0, or this factor is going to be 0, and then the whole expression will be 0. So either x minus 1 is 0, or x plus 3 is 0, and this gives us x is equal to 1 and x is equal to minus 3. Those are the two roots, or the zeros, or in this case they prefer to call it x-intercepts. The y-intercept, where the graph or the curve is crossing the y-axis, happens when x is equal to 0. So we just substitute x is equal to 0 for, well, sorry, substitute 0 for x into this function. So 0 squared plus 2 times x, which is 2 times 0 in this case, minus 3, and then we just work it out and we see that it's minus 3. So the y-intercept occurs when y is equal to minus 3. Now, the last thing, we know from before a way to find out the x value of the turning point, because if the function is a U shape and we have the two zeros, we can just find the middle value of these two x values for the zeros, and that will be the x value for the turning point. There's another way to do it. We can use the derivative. So let's have a look at this. Calculate the derivative. So the derivative of the function would be 2x plus 2. Why? Well, 2x plus 2. So we move the 2 in the exponent in front, it becomes 2x. Decrease 2 by 1, we're left with 2x to the power of 1, or just 2x. And then the second term is 2x, or plus 2x. It will become just 2. And then the derivative of this term, minus 3, is just a constant, so it will be nothing. So the derivative of the function is 2x plus 2. Now, set this is equal to 0. Why? Well, let's actually back up a little bit and have a look at this function. Let's draw a graph. So x squared plus 2x minus 3, right? X squared plus 2x minus 3. This looks like this. Okay, we have the zeros here, minus 3 and 1. We could just take the kind of the middle point of minus 3 and 1. We would find out that it would be minus 1, and we see that that's the x value for the turning point, in this case the minimum. But if we think about it, if we would have a point that's moving around on the curve, walking around on the curve here, and then we find the tangent at this point as it's moving. The tangent here at the minimum Let's analyze the graph. Minimum. Now I would like to have the tangent right here where x is -1. Geometry, points and lines, tangent, and okay, we have to plot the point. Okay, no problem. Geometry, points and lines, point on. I'm going to choose this point. Okay, and now we can draw the tangent. Since we already had a point there, this is actually how you undo it. Control, escape, control, escape. Let's plot one point. Let's not do the minimum. Point on, and we know that it's -1, -1, enter. This is our point. Now let's get the tangent. There we go. This is the, oops. This is the equation of the tangent. Okay, y is equal to -4. So there's no slope, there's no x term here. We don't have a function like y is equal to 2x minus 4, or y is equal to minus a half x minus 4, or y is equal to minus 3x minus 4. There's no x term. That's because the slope is 0 when we have a horizontal line like this. So going back to our example, that's why we would like to find out when is the derivative, or this, when is this slope 0 for what x value. So we just set the derivative of the function equal to 0. Now we solve this function. 2x plus 2 is equal to 0. Move plus 2 to the right side, becomes -2. Divide both sides by 2. 2x divided by 2 is x. -2 divided by 2 is -1. So x is equal to -1 for the turning point of the curve. Okay, so that's another way of finding out the x value for the turning point. Now try to do the same thing here in exercise 1 and follow the steps that we can see here in the example. So first of all, you find x-intercept, or zeros or roots. We just factorize it and then solve the equation when this expression is equal to 0. We'll get 2 values of x. And then the y-intercept, we'll just let x be 0 and substitute 0 into the function. And we'll get the y-intercept, the y value. Then to find the x value for the turning point of the curve, let's have a look at this function. This is also positive. We also have a positive x2 term, which means that it's going to be u-shape, and we're going to have a minimum. Okay, so find out what the derivative of this is. Solve the equation when the derivative is equal to 0, and then find out for which x value that is true.